I'm Anil Kumar. In this video, we'll discuss intersection of planes with the help of 4 examples. Now, these examples will also remind you of different cases which we could have while dealing with intersection of 3 planes. So you can actually pause the video, copy this question, work it out, and then look into my solutions. So let's go through them one by one. We have 3 equations given to us. X minus y plus 9z equals to 10, minus 4x plus y minus equals to 0, minus 2x plus 2y minus 18z equals to 1. In how many points will these 3 planes intersect? This is what we have to figure out. Now what you notice here is that equation 1 and equation 3 are related. If I times this by minus 2, the first one, I get the second equation, right? Only the normal vectors, right? The constants are different. So what we notice here, that the normal vector of equation 3 is basically minus 2 times normal vector of equation 1. So they are parallel. So we have parallel planes. Since these values, that is to say, let me say D1 is not equal to D3. Right. So definitely when we have 2 parallel planes, then what could be the intersection between 3 planes? Well, the answer is there will not be. So the system is inconsistent. No solution. Perfect. You could actually represent this kind of like this, that one plane is here and the other plane is, let us say, somewhere there. So they will not intersect. However, the third plane could go through them, right? So the third plane could go through them and could have an intersection, let's say something like this. Intersect both these planes with lines, right? So that is possible. Let's look into the second case, which is 2x minus y plus 3 so we get 2x minus y plus z equals to 3, minus 4x plus 2y minus 2z equals to minus 6, minus 2x plus y minus z equals to minus 3. Now in this case, what do we observe? Here you see that if I multiply equation 1 by minus 2, let's say, so if I do this times minus 2, I get the complete equation. And the last equation I could get if I multiply this by minus 1. Correct? So that basically means that we are actually working with same planes. Right, so they are scalar multiples. Think like this. So we have 3 planes which are coincident, right? So we have 3 planes which are coincident. So in this case, what is the solution? So in this case, the solution is of a plane, all the same planes. Perfect. So since they are same planes, right? So we know that plane 1 is actually equals to plane 2, which is also equals to plane 3. So they are coincident, right? So the solution is a plane. You can provide any one of these equations as your solution, right? Now let's look into C and D. C is 5x minus 2y minus z equals to minus 6, minus x plus y plus 2z equals to 0, 2x minus y minus z equals to minus 2. Now here clearly the normals are very different, right? So they are not equal or scalar multiple as they were in the previous two cases. So here we might have intersection of these planes as a line or a point. So let's look into it in further details. So I've taken up C once again. So what we have here is the three planes: 5x minus 2y minus z equals to minus 6, minus x plus y plus 2z equals to 0, and 2x minus y minus z equals to minus 2. So we can write them in the augmented matrix form and solve. Right? So the first step here is to write augmented matrix. We would prefer to keep the equation with simplest coefficient first. So we'll rearrange. So I'll move this equation to the top, right? And bring the first equation at the end. So we'll write this as, let's say, only the coefficients we are going to write, right? So we have minus 1, 1, and 2 equals to 0. Second one, I'm writing this one, which is 2, minus 1, minus 1, minus 2. And the last one is 5, minus 2, minus 1, minus 6. So that is the augmented matrix. Now we will do matrix operations to solve these simultaneous equations. The idea is to get 0 for these two positions, right? That is the idea. That is the first step. So what we can do here is, we can do add R2. Let me copy the first one and then we'll continue. Okay, so we'll copy the first one, which is minus 1, 1, 2, 0. And now to get 0 here, we can do R2 plus 2 times R1, right? So plus 2 times R1. So if you do that, twice minus 1 gives you minus 2, and when you add them, you get 0. That's the idea, right? 2 minus 1 is 1, 4 minus 1 is 3, 0 minus, we have to do R2 times, so I'd here. Now the idea is to make 5 as 0. So we could add 5 times R1 to R3. So we can write this as R3 plus 5 times R1, right? So 5 times will give us 0 here. 5 minus 2 is 3. 10 minus 1 is 9. 0, we have to add, I'm sorry. So 5 times, that is okay, that is minus. 5 times this is okay. 5 times 2 is 10, we have to add this, we get minus, we get 9, that is also correct, we are adding. And when you add this, you get minus 6, correct. So we have got these two zeros. Now we should get that 0 to get the point of intersection. So we are heading towards point of intersection. Now let me take it to the right side. We'll copy the first two equations as such, which is minus 1, 1, 2, 0. Then we have 0, 1, 3, minus 2. Now to get 0 at this stage, we'll use R2. So we can do R3 minus 3 times R2. That should give you 0 in the center. So that becomes 0. So 3 times 3 is 9. 3 times 3 is 9. So we are doing minus 3. So minus 9 plus 9 is again 0. So this is also 0 for us. And here, what do we get? 3 times minus 2 is 6. right? So we get 6, and if we take away 6, we again get 0. So what you notice here is that 0 equals to 0. That means we have one parameter. So that means the intersection is a line. So line is intersection. Is that clear? Now, from the other two equations, we can actually write down the equations and get the solution. So 1, 3 minus 2, we could say y plus 3z equals to minus 2. First equation, we could write this as minus x plus y plus 2z equals to 0. We need to avoid any fractions, right? So what we will do here is that we will assume z as the parameter t, right? So we can assume that t is the parameter t. If z is t, then we can rearrange the first equation, get the value of y. Correct? So from here, we get y equals to minus 2 minus 3z. Now z is t, and therefore we can write y equals to minus 2 minus 3t. Is that clear? So we get z equals to t and y equals to minus 2 minus 3t. So we can get x in terms of y and z. Right? So we could write here x is equals to y plus 2z. Y is all this, which is minus 2 minus 3t, plus 2 times z gives us 2t, and combining these terms we get minus 2, and minus 3t plus 2t is minus t. We get the value of x also. So that gives you x as minus 2t minus t, y as minus 2 minus 3t, and z as t. So we get the equation of the line of intersection as, so the point here is minus 2, y coordinate also minus 2, and z coordinate is 0, plus t minus 1 minus 3, and this gives you 0, right? Where t belongs to real numbers. Is that correct? So that is how you can provide vector equation of the line as a point of intersection for the given plane. Perfect. So I hope the solution is absolutely clear. Actually sketch it. Sometimes that may be the requirement. This is one plane. The other plane actually intersects at this line, for example. So the plane could be sketched kind of like this. The third plane, which intersects at the same line, could be shown as kind of like this. Is that clear? So that becomes the line of intersection of these three planes. So I hope with this you understand how to use augmented matrix to solve simultaneously the three equations of the planes and the solution. So this is a consistent set of equations where the planes intersect in the given line. Now let's take up part D. Here is part D. We'll try to find point of intersection for the given planes. The equations are x minus y plus 2z equals to 10, 7x plus 8y minus z equals to 10, and minus 6x minus 5y plus 2z equals to 12. So let's write down these equations in augmented matrix form, which is 1. We are just writing the coefficients, right? And the constants on the right side. So that is the augmented matrix. You can actually rearrange these two equations. It's a good idea to write that equation before this, so we can actually rearrange them. That gives you 12. The third equation is 7, 8, minus 1, 10. The idea is to get zeros for the corner. Right? So this corner, we have to get 0. Plus, we'll also get 0 for the position above it. Row 2, column 1. Now, to get a 0 here, what can we do? Let's first rewrite the first row, which is 1 minus 1, 2, 10. To get a 0 here, I have to multiply first row by 6 and then add, right? So what I get here is 6 times R1 plus R2. You get 0 here. 6 times gives you minus 6, and when you add, you get minus 11. 6 times 2 is 12, plus 2 is 14. 6 times gives you 60, 72. To get a 0 here, we have to multiply by 7, right? And then we can actually take away. So what we can do is, we can do 7 times R1 and take away R3. 7 minus 7 is 0. Now, minus 7, take away 8 gives you minus 15. 7 times 2 is 14. 14 take away 1 will give you 15. 70 take away 10 will give you 60. So that is what you get. Now we have to make this as 0. So that is the next step. How can you do that? To get this 0, what we should do is we should multiply by the fraction 15 over 11, the second row, right? 15 over 11. And then we could be in a way to get the solution, right? So that is what we will try. So let's try to do it here. We'll rewrite the first two equations, which are 1 minus 1, 2, 10. Second one is 0, minus 11, 14, and 72. The third one, we want to make this 0. So we'll multiply the second equation by 15 over 11. So we get 15 over 11 of R2. Then we'll take away R3. Right, so this remains as 0. Here, when you multiply by 15 divided by 11, you get 15 minus on the top, and when you take away, you do get 0. Let's do the next one. So it is 15 take away. Let's use the calculator. So we'll do 14 times 15 divided by, okay, let's do it. So we get 14 times 15 divided by 11. And from here, we'll take away 15. So we'll do minus 15 equals 2. So let's write it in the form of fractions. So we get 45 over 11. So here we get 45 over 11. The next one is we have to divide 72. Divide this by 11. And then we'll multiply by 15. And then we'll take away 60. And in fractions, we get 420 by 11. Now, in this situation, you can clearly see that we have a point of intersection, right? So that gives you the J equation. So we have 45 over 11 Z equals to 420 over 11. So from here, we can find that Z is equal to 420 divided by 45, correct? So let's do 420 divided by 45 in fractions, it gives us 28 over 3. Right? So that is the z value, 28 over 3. The next equation here is minus 11y plus 14z equals to 72. So from here we can get the value of y, right? So we can get here, rearrange. So we get y equals to, taking it to the right side, we get 14z minus 72 and everything divided by 11, so 1 over 11. Perfect. Now substituting the value of z as 28 over 3, we get y as equal to 14 times 28 over 3 minus 72 and all this divided by 11. Right? So let's use the calculator again, find this answer. 14 times 28, and we are going to divide this by 3, take away 72, and then we are going to divide this by 11. The answer we want in fractions, 16 over 3 is what we get. So we get this value as 16 over 3, right? So we get y coordinates as 16 over 3. Now we can use the very first equation to find x. It is x minus y plus 2z equals to 10. X is equals to y minus 2z plus 10, which is y is 16 over 3 minus 2 times z is 28 over 3 plus 10. So let's calculate this also. So we have 16 divided by 3 minus 2 times 28 divided by 3 plus 10 equals to, in fractions, minus 10 over 3, minus 10 over 3. So we do get a point of intersection as our answer. So let's rewrite or write down the answer now. So our answer is that these three planes intersect at a point whose x coordinate is minus 10 over 3, y coordinate is 16 over 3, and z coordinate is 28 over 3. Perfect. So that is how they are going to intersect. At times in your test, it may be required to show the planes intersection diagram also. So you could do it something like this. Let's say these are the two planes which will intersect in a line. So plane 1 drawn in green, the plane 2. Let me just sketch it like this. And the third plane actually goes through it. So, and let's say this is the point of intersection. So it goes kind of like this through it. So I could draw the third plane as kind of like this. Do you see that? Okay, so that could be my third plane going through the point of intersection given to us here. So I think with this example, you understand how to solve intersection of three planes using augmented matrix. So I hope with this you learn how to find intersection of planes, especially when three planes are given to us. And with these 4 examples, we have actually considered all the cases which normally you can come across. Intersection at a point, intersection in a line, in a plane, or not intersecting, two planes being parallel. Feel free to write your comment, share your views, and if you like and subscribe to our videos, that would be great. Thanks for watching and all the best.